Welcome back. We're looking at lesson number 7 in the Algebra 1 curriculum, and today we're going to analyze functions. The 3 activities we have are a Desmos activity. The bulk of your time will be in that activity, and then characteristics. These are going to be in your slides, and then connect the dots. And on that, it's a pretty quick activity. Kids are just going to complete domains to connect some 5 points on a graph. The activity is called Graphs of Functions, and it has 14 slides, and I would say this is one I would go at a slow pace because it's another one of these foundational assignments. It's kind of laying the groundwork for future assignments. So conversations are important. Getting kids to slow down and look at details here is important. Asking lots of questions, and they're going to wonder, why are we going so slow? Well, we just have to in this case because we want to make sure they don't miss some big idea that's going to be with them for the rest of the class. So in this assignment, we're focusing on domain and range, which they've already talked about, and we're adding to it intervals of increase and decrease. I don't know why my X got cut off, but it did. I've given you literally a book to read down here, so be sure that you read all this text. I would do it before I even start the class because I'm giving you some pointers. These are things I've experienced as a teacher in 36 years of issues. When they write domain and range and they're moving from right to left on the graph, they can get technically a right answer without really knowing what they're doing. So I really do ask them over and over, can you rewrite that same thing you just wrote and make it go left or right? So you'll see what I mean as you read these notes, but I'm kind of harping on that. And the kids I know look at me like, why does it matter so much? Well, I know it doesn't matter to kids, but it will matter later. So anyway, read these notes. I did write quite a few for you, and also I would consider pacing the kids to stay with you so that you can have some good conversations. And you do want to try to get the kids to say it. You don't want to just tell them, because if you just tell them, as soon as it comes out of your mouth, it's going to be out of their mind. They're not going to remember it. But if you ask them to say it and question them and get them to come up with the answers, they'll do a little better. So on screen 2, we're looking at an interval of increase, and they're going to use these sliders to kind of help them. One thing I like is that these will not go past the domain of the function, so that kind of limits them. And see, when they do this correctly, it does say super, so that they know that they got that part right. But then they still need to answer the questions. The player starts going up when, at how many seconds, and then they stop going up when. So that would be something that they'll need to do. Also, during this time, I would have the teacher dashboard up for the kids so that they can see what it is that they're doing. They will see a check mark if they get something right, and they will see an X if they get something wrong. And so that's a way for them to check themselves. And you don't just leave their names up there for all of the class to see. They have a feature called Anonymize, and if you've not used it, I highly recommend it. What it does is it takes all the kids' names out and replaces them with famous mathematicians, and the students on their dashboard will see the name of the mathematician that's assigned to them so that they can look up at that screen and see that name and go, oh, that's me, and they'll be able to keep track of if they're getting things right or wrong without revealing who they are. Now, a lot of kids will tell the kids who they are, and that's their decision. I'm fine with that, but I don't want to out some kid that's not doing well or is doing well without them doing it. So that's something that I do regularly. So on screen 3, we want to know when the height in feet is decreasing. They do have to get that shading in the correct spot and have the right answers to get that check mark in the dashboard. So just call attention to that in case they didn't get their check mark and they're like, why didn't it work? I know this is right. Some of them ignore the graph and just go straight to the text. And some of them ignore the text and go straight to the graph. So you got to make sure they do both parts. And in this one, they want to know the domain of the entire jump. So that would be from the here to here. And then down here at the bottom, I'm kind of going back to the function notation. Like, why do you believe the variable t was chosen? And they may notice, oh, that's time, so t for time. Why do you think the variable h, or the function name h, was chosen, h for height? So let them tell you instead of you telling them. So ask those questions and get the kids to volunteer answers to those questions. We're trying to pull back in something they've learned in a prior lesson here. And as you will see as we go through most of our activities in this class, we're going to continually be pulling things in that they've done before repeatedly throughout the course. When we get to this one, it talks about being in a context. And sometimes in a context, the only numbers that make sense we use for the domain. But just because it's the domain in context may not be the domain of that function without a context. Like this function, if it were a real life, might start at 0, but if I don't care about real life, I can go ahead and move it all the way back into the negatives. You can also discuss down at the bottom here, I've given some more notes, that negatives sometimes do work in a context. You can have negative temperatures. You can go back in time if, for example, you set today as day 0, well then yesterday could be day -1. So it is possible to do it. The kids can do a second example if they click here to do domain. So there are 2 examples here for them to look at. There is no work on this screen, but they do need to move the domain. Well, I guess there's no work except for putting the slider where it goes. This one is domain and range. Now this one does let them go farther than the height of this graph. For this one, they're reading from left to right and they're answering. Now this is really just stripped down kind of problems, which I don't like to do much of anyway. But we're doing them because they do have to be able to do them for state tests and for other reasons. So we do put a few in, and here's one. But if your kids get stuck, like they're sitting here staring at this and they aren't even sure what it's saying, and that's going to happen with a few of your kids probably, I did include the graphing calculator. So when they click on this, they can type x is less than 3 or x is less than or equal. You put an equal sign right after that and it'll put that little bar. And they can look at the shading in the graph and see if that makes sense for the function that's in the graph. So I don't really point that out to them right away, but if I do notice a kid is just sitting here and frustrated, or if they're just guessing and checking without even trying to look at the graph, then I'll direct them to the calculator. I'd rather them use the calculator and see it and get something out of the problem than not. So anyway, the shading sometimes helps, and it's there for them, so they should use it. Now this one says click and drag along the graph to examine values. So something they should be doing anyway is when they click on this graph and move around like this, they can see the numbers. 2's around in here, and there's other numbers to the left of that. But a lot of kids think these parabolas stop. They don't. So you could actually click and go a little off the graph here. Another notation is right here. X is an element of the real numbers. That means all real numbers, and that one is one of the true statements. This goes forever to the left and the right. Even though you can't see it, it goes off the screen, it does continue. They do need to select 3 answers on this screen, and again it'll show them a check mark on the dashboard when they find all of them. And then here's one that's a little different. All of these statements are false, so it's important that your kids know none of these are right. They're all incorrect. So choose one and then explain why it's false. So the one at the bottom, and I don't know why this is, but kids like to call every domain all real numbers. I mean, that's something I've noticed from year to year. It's like, why do y'all think that? I guess because we do use it a lot, so they just pick it all the time. But here's an example where it's not all real numbers, so tell me why. And then the range is given, what's wrong. So they could correct it, or they could say why it's not, or whatever. Class discussion is super important in this assignment. So after each slide, I would restrict them most of the way through this and call on teams over and over. Like, okay, team 2, what did y'all pick? You know, and then they usually have 1 or 2 kids that'll pipe up and tell me, and then I'll say, why did you pick that one? And what did you say? And did a different team, did y'all pick that one? Did you say the same thing? You know, so we might do something like that, but get lots of conversation out of the kids. It helps them to make sense of what they're doing when they have to explain it to someone else. And then again, more notes. I'm thinking this is probably a bigger assignment for the teacher than for the kid, but I did put a lot of text down here at the bottom for you to read. I'll give you one example, something kids do a lot. They'll type for an inequality. Let's say the graph is increasing to the left of x equals 1. Well, you could say 1 is greater than x, which is true. 1 is greater than x, and x is less than 1, which are equivalent expressions. But we want to lead them towards the x is less than 1 for multiple reasons. For one thing, it makes sense, intuitively makes sense. If the graph on the left side of the 1, less than the 1, is going up, if you read from left to right. When you read it backwards, especially in that way, it's harder for them to make sense of it. Having said that, they are reading their compound inequalities backward too, so maybe some of those kids can do it. I don't know, but I just know this is a problem, and it's one of those things that kind of sticks with them. So I usually slow way down on a lesson like this, and we just kind of go deep into this and make sure we know how to write things. And if they write it the other way, I'm not going to count it wrong, but I do want them to move towards the preferred notation, which is put the variable, then put the symbol, and then put the number if you are writing something that is open on one side. Like if it's increasing everywhere to the right of 4, you would say x is greater than 4, or if it's decreasing. One other thing is they can put less than or equal, and they can put less than. They don't have to put the equal. They can leave it off or use it. That's typically not something that's counted off. If they were being tested on it, I would never count off for that. But there's a big debate as to how could you increase at the end of the interval. And that's a real philosophical thing. And if you've got a group of kids that loves to talk about that stuff, you can get into that conversation. But just know half your kids will be rolling their eyes going, I don't know what y'all are talking about. But those end points of the intervals, I do not really assess that. I just want to know they know where it starts and where it stops, and whether to include those endpoints or not is kind of up for debate. And then here's another one. Type in compound inequality, and you'll notice I did not include the equal sign on the where's the function decreasing. I just want them to put 2 numbers in place of those question marks. At this point, I would open up all the screens to all of the activity, all sides, and let them go back as needed to look at answers and review their work, correct, finish, because I would have been restricting them a lot up to the end of this assignment. So I do want them to have the ability to go back. Now this is a card set. They're going to do 4 sets of cards. So you could start with your 4 graphs and put them up here, and then they could, match all these other things to them. So they do have 2 challenge slides. Both of these would be eligible for their portfolio because they're sketching a graph that has certain characteristics, but there are literally an infinite number of ways to sketch it. They could make it curvy or straight or not. So anyway, the domain's given. It's increasing on one interval and it's decreasing on another. So there's some limitations to what they can do, but there are differences they could have. So sketch something. This would be good to share with the class maybe towards the end of class to see what they came up with. And then sketch 2 is they're given a domain of all real numbers. So the graph should go off forever left and right, and the range is less than or equal to 6. It should be increasing on the interval x is less than 0 and decreasing on the interval of x is greater than 0. So this would also be eligible for their portfolio. So this activity doesn't have a time on it here, but it's, I'd say, a minimum of half your class period or more, depending on how long your conversations are and depending on how well your kids are doing. Because this is one, it's worth the extra time that you take. So if they're not doing well, it's to their benefit and yours to slow down and let's get this right, because we do want to be able to use this on future assignments. Most of their assignments are going to use some of these concepts, so it's a big one. So the next activity is characteristics of functions, and it's in your slides. And so you're given a graph of an object just thrown upward and allowed to fall to the ground under the influence of gravity. And so they are to tell me 3 things that they notice in this graph. Something you notice about this object, what is it doing? And then, is this function linear or nonlinear? So again, we're pulling back in something from a prior lesson. We don't want to forget what those words mean, so we use them a lot. And then I'm going to ask them to complete the domains and ranges. Now, I did kind of intentionally, let's show you this. I threw a little question in here, and this is for your kids that take notice. Look closely at this graph. Can you determine an exact value for the maximum height? You might notice that point that's at 1, it's not exactly the maximum. It's kind of off a little bit. It's really a tiny, tiny bit to the right of that. Now, if they don't notice that and just use the 90 as their maximum, that is perfectly fine, because 90 is super close to that point. But there may be a kid that notices that, and I want you to jump up and down and get really excited and go, that is so awesome that you noticed that. I really like that. So our goal is to get kids to stop and not make assumptions and not just assume the teacher told them so it must be true, or they read it in an assignment so it must be true. Always, always have that eye open for little things like that. So this would be a good one to stop and pause and talk about if you have time. You may not, but we're reviewing domain and range here, and I think that was kind of an intentional thing that I did, kind of a happy accident, if you will. So I do hope that some student notices that this maximum is not right on that little red dot. And so that may influence some of their answers. So as you're checking these answers, just notice the maximum is really 90.25 or something like that. It's 90.125. It's really close to 90, but it's not exactly 90. And on this one, they're going to tell me when or where is this increasing and where is this decreasing. We're only using values of x for this, so they only look down at the bottom on the x-axis to determine what numbers to put in there. Then for this one, I'm asking them to tell me h of 0 equals what. So in this one, this was probably going to be harder because we've only done function notation a couple of times. It's been a couple of days since they've looked at it, and they may be getting these backwards. So another discussion about that number in the parentheses, that is your input, and the number what it's equal to is your output. So we think of that number inside the parentheses like our x, and the number outside as our y. You could also discuss the fact that the name of the function is h. Why do you think that is? Well, it's the height of something. So anyway, they will fill in these numbers and then give it a description of what these represent in this context. All right, and that's that one. So then we have a different scenario about Jack and his scooter. So what is Jack doing? Is this realistic? Why or why not? So here's another example of a typical textbook problem the kids may see. I did make it up, but it's not realistic, I don't think. I hope your kids know that, and if not, encourage them to come up with some reasons why this may not be realistic. He's 120 miles and he's riding a scooter. I don't know. Most people don't ride a scooter for 120 miles. I mean, I guess they could. It took him 6 hours to do it. So he's going an average of, I guess, 20 miles per hour. I mean, that's not terribly unrealistic. But I think the most unrealistic thing is, where is he traveling that he would not move at any other rate? That he would go exactly that rate the whole time without stopping, slowing down, speeding up, nothing. Just perfect the whole 6 hours. I don't know. That doesn't seem realistic to me. So I wouldn't tell them any of that. I wouldn't say a word about any of the things I just said. But I would try to see if any of the students could come up with some crazy reasons why this does not make sense. Jack is weird if he can do this. I don't even know. So I'm intentionally throwing these in these assignments, and I do it all year long. So I want kids to always be on the lookout. You might even give them an award or some kind of prize for picking stuff out, like noticing, oh, look what you noticed. I'm glad you noticed that. Here's a piece of candy. Do something to encourage them to notice these things, because in the real world they're encountering crazy stuff all the time, and they don't need to just accept things at face value. They need to question them. Then this one is again asking linear or nonlinear. Why? What does that mean in this context? Well, he's going at the exact same rate the whole time. Is this function increasing or decreasing? Well, it's only decreasing. So it's as the time goes on, his distance is decreasing. And then in this one, they're doing the domain and the range in context. What does it mean? Well, the domain has to do with the number of hours. So his domain is all the times for his trip. And then the distance would be his range. That's all the different distances for his trip home, or how far his trip was from his home. And then the last one is again function notation. Now this time I gave them no numbers. I'm just giving them a description, and then they're going to pick out of the graph the numbers that make sense for that description. So the first statement was about starting his ride, and starting his ride, the point 0, 120 is the point at the start of the ride. So he would use those numbers in function notation. Halfway through the ride would be halfway through this segment, which would be right at 3 on the x-axis, and I believe, let's see, that's 60 on the y-axis. And then Jack ended his ride. He ended his ride when he made it home. So at 6 being 6 hours, he was at home. So that's what he needs to type for the description of what it means. But be sure they use units. So we need to put the words miles and hours in these statements. And then finally, the last part of this assignment is pretty quick. We're going to connect the dots by going to this graph. This is a Desmos graph where I've just plotted some points, and I went ahead and left the order pairs on there. And I've given them equations for lines to connect the dots, but they have to complete the domains. I will be doing a quick demo video. It'll be a YouTube short about how to change these question marks into these numbers to insert the graph and the equations onto the slide. So be sure to check for that YouTube short. So if you have any questions about this assignment or any of the others, let me know. Please let me know if you notice an error or something missing. I had a person reach out to me and tell me one of my links was broken on the site, and I would have probably not known that for weeks if they hadn't told me. So if you catch something and want to let me know, feel free to. That would be nice, and I will get it fixed for you, because I do want these resources out there for you. Y'all have a great day.